Hello, Sir Fadzly. Today my team will be present about Boeing 777. My name is Mathialagan Analaki Ganesh. My ID number is 5310612025. I am from class 3 AM2. Let me talk about the simple basic introduction of Boeing 777. The role of this aircraft is wide-body jet airline. The national origin is United States. The manufacturer of Boeing 777 is Boeing Commercial Airplanes. The Boeing 777 first flight is on 12 June 1994. Boeing 777 is operated by Cathay Pacific. The number of units built is 1090 as of March 2013. The seating capacity for this aircraft is 301 until 550. The primary users of Boeing 777 is Emirates, United Airlines, Air France, and Singapore Airlines. The maximum speed for Boeing 777 is 590 mph, 950 km per hour. Boeing 777 is the very first commercial jet to be designed entirely on the computer. No paper drawing of 777 were ever produced. Boeing 777-200LR is the world's largest range commercial airplane. The B777 was awarded a trophy by the US National Aeronautic Association, which honored it as the top aeronautical achievement of 1995. The B777's landing gear is the largest ever incorporated into a commercial airliner.
So next is we're gonna talk about the specification of Boeing 777. So first thing first is they have two flight crew, and then the capacity is between 301 to 550, and then the length is between 63.7 meter to 73.9 meter, and then the wingspan is between 60.9 meter to 64.8 meter, and then the wing sweep back is 31.64 meter for the all Boeing 77. Next is the wing area. The wing area is between 427.8 meters square to 436 meters square. Next is tail height. The tail height for all Boeing 77 is 18.5 meter, and then the cabin width is 5.87 meter. Next is the fuselage width. The fuselage width is 60.2 meter. The empty operator weight is between 134,800 kg to 8,867,800 kg. And then the maximum landing weight is 2,840 kg to 251,290 kg. And then the maximum takeoff weight is 247,200 kg to 351,050 kg. The next one is typical cruise speed is at Mach 0.84. So the velocity is 905 km per hour, which is 490 knots at a cruise altitude of 35,000 feet at 1100 meter. And then the maximum cruise speed is at Mach 0.89, which is 950 kilometer per hour and 512 knots at a cruise altitude of 35,000 feet at 11,000 to 11,000 meter too. And then the maximum range is between 9,000 and 700 kilometer to 13,649 kilometer. And then the takeoff distance in international standard atmosphere at mean sea level is between 205 2000 and 2,530 meter to 3,000 to 200 meter. And then the maximum fuel capacity is between 117,000 348 liters to 181,000 to 283 liters. And then lastly is about the service ceiling is 43,100 feet at 13,140 meter.
No, aircraft flight control are the means by which a pilot controls the direction and attitude of an aircraft in flight. Flight control systems are subdivided into what are referred to as primary and secondary control systems. Primary control systems are required to safely control an aircraft during flight and consist of aileron, elevator, and rudder. Secondary flight control are intended to improve the aircraft performance characteristics to release excessive control loading and consist of high lift devices such as slat, flap, and trim system. Now let's talk about the primary and secondary flight control system of Boeing 777. The principle of Boeing approach by fly-by-wire electronic flight control system were established with the Boeing 777. The design principle adopted is to provide a system that responds similarly to a mechanical control flight system. Because B777 system is controlled electronically, it is also able to provide flight envelope protection. The electronic system operates on two levels. The first one is Actuator Control Electronic Unit, ACE. The second one is a Primary Flight Computer, PFC. The ACEs control actuator from those on pilot control the surface, and PFC determines the applicable control laws and provides feedback, force, pilot information, and warning.
The inputs given by the pilots on the control stick are converted into electrical signals by different transducers that are installed at the base of the control stick. The transducers will determine how much pitch or roll maneuver is demanded by the pilots and sends this information to the flight control computers. The flight control computers analyze the incoming signal and determine how much the control surface needs to be moved to obtain the required output. The computer will consider different factors such as the speed at which the aircraft is flying, the altitude of the aircraft, and the current position of the control surface. Based on these factors, the computer decides how much deflection is required on the control surface and sends the commands to the actuator accordingly. After the control surface is deflected, the computer receives a feedback signal from the control surface. The computer now has information on the actual position of the control surface. This is compared with the response of the aircraft. This is done by getting information from different air data computers which are connected to the aircraft's pitot and static tubes. This is extremely essential in flying the aircraft safely.
The Boeing 777 is a formidable flying machine that greatly enhanced aircraft handling qualities, increased safety and reliability, reduced system weight and maintenance costs, and let the pilot have ultimate full authority over the ship at all times by flight control system fly-by-wire.
Hello, I am Rajana Shafika and I will be explaining about Boeing 777 fly-by-wire system. Fly-by-wire is a term of flight control system that use computer to process the flight control input that were made by pilot or autopilot and send the electrical signal to the flight control actuators. The fly-by-wire arrangement replaces mechanical linkage, which means the pilot input doesn't directly move the control surfaces, but instead input are read by computers and in turn to determine how to move the control surfaces to achieve what pilot wants according to which flight control laws that is active. The fly-by-wire system basic components in Boeing 777 consist of primary flight computers, PFC, actuator control electronics, ACE, power control units, PCU, and ARINC 6 to 9 data buses. The fly-by-wire system works as what I'm showing. First, the pilot will generate an input signal by manipulate the primary flight controls. Then the analog signal will be received by the ACEs, which will digitalize it and redirects it to the PFC via the ARINC 6 to 9 data bus. The PCF will constantly gather and monitor information from AC sources and will then generate actual control laws by enhancing the received signal. The PFC generated control command will then be sent back to the ACEs, which will in turn convert it to an analog signal that the PCUs will use to move the control surfaces. When the autopilot is engaged, it communicates directly with the PFC. Operating modes of fly-by-wire or flight control laws is as follows. Normal law, full system functionality, which is normal operating mode. Secondary law, degraded mode with limited functionality. PCF will provide control laws, but protection features are not available during secondary law. The last one is direct law. PFC are not available. System reverts to a direct pilot to control surface logic. Direct law can be activated by disconnecting the PFC. The airplane are mostly flown in normal law. When the PFC detects inconsistent information or a sufficient number of failures, it will be reverted to second law. If the PFC is failed altogether, then the system will revert to direct law. The aircraft handling in secondary and direct modes are very similar. The difference is that in direct law, the PFC are not operating the control law for the actuators.
Hello, my name is Mohammad Fadzly, and today I'll be explaining about Boeing 777 backup flight control system. So mechanical or manually operated flight control system are the most basic method of controlling an aircraft. The Boeing 777 was Boeing's first fly-by-wire commercial aircraft, and by that time several generations of Airbus aircraft had gone fully fly-by-wire, so confidence was much higher in the system. The horizontal stabilizer and a set of wing spoilers were the mechanical backup on the triple-channel fly-by-wire system, which by then had become standard on the aircraft. So now we'll move on to Boeing 777 horizontal stabilizer. So now, as you can see, I'll explain what is a horizontal stabilizer first. So at the rear of the fuselage of most aircraft, one finds a horizontal stabilizer and an elevator. The stabilizer is a fixed wing section whose job is to provide stability for the aircraft to keep it flying straight. The horizontal stabilizer prevents up and down or pitching motion of the aircraft nose. The elevator is the small moving section at the rear of the stabilizer that is attached to the fixed section by hinges. Because the elevator moves, it varies the amount of force generated by the tail surface and is used to generate and control the pitching motion of the aircraft. There is an elevator attached to each side of the fuselage. The elevators work in pairs. When the right elevator goes up, the left elevator also goes up. So here's a picture of a Boeing 777 horizontal stabilizer. So what you are seeing is a flat area on the curved fuselage. The flat area allows the horizontal stab to move without creating a gap between it and the fuselage. If you look closely, just forward of the horizontal stab, you'll find 3 black marks. The top one indicating the maximum up position, the next being neutral, and the bottom one the lower limit of movement. In 777, the fuselage body is so wide and they have to flatten the rounded body just after the pressure bulkhead in order to allow space for trim movements. The Boeing 777 has a movable tailplane which is used to trim the aircraft in the pitch axis. The tailplane pivots near the central point of its chord. The tailplane's leading and trailing edges will sweep through the surface of the curved fuselage at those points. The flat surfaces on the fuselage where they meet the tailplane permit the tailplane to pivot without interference with the fuselage. This structural feature is common on transport aircraft with the tailplane attached to a tubular-shaped fuselage. So now we'll move on to 777 spoiler. So right now I'm showing you a picture of the Boeing 777 spoiler system. Alright, so now is a real picture. So if you notice, there is one spoiler that isn't totally deployed. So I'll explain. Roll control is provided by 2 flaperons, 2 ailerons, and 14 spoilers. So spoiler panel 4 and 11 and the alternate stabilizer pitch trim system are controlled mechanically rather than electrically. Spoilers 4 and 11 are driven directly from control wheel deflections via a control cable. The alternate horizontal stabilizer control is accomplished by using the pitch trim levers on the flight deck aisle stand. Electrical switches actuated by the alternate trim levers allow the PLCs to determine when alternate trim is being commanded so that appropriate commands can be given to the pitch control laws. Spoiler panels 4 and 11 are also used as speed brakes, both in the air and on the ground. The speed brake function for this spoiler pair only has 2 positions, stowed and fully extended. The speed brake commands for spoilers 4 and 11 are electrical in nature, with an ACE giving an extend or retract command to a solenoid-operated valve in each of the actuators. Once that spoiler pair has been deployed by a speed brake command, there is no control wheel speed brake command missing, as there is on all the other fly-by-wire spoiler surfaces. So that's all from me today. Thank you.
The conclusion for Boeing 777 is, throughout the years, Boeing has actively been listening to their customers and made some improvement to achieve their demand that prove from result in a variety of models and versions of the Boeing 777. 3 engines offering are available with the Boeing 777, the General Electric GE90, the Rolls-Royce Trent 800, and the Pratt & Whitney PW4000. The 777 holds the record for the longest flight of a commercial airliner and is capable of flying more than halfway around the world. The Boeing 777 is the Boeing best-selling aircraft. The Boeing 777 is fuel-efficient aircraft. In market currently focused heavily on fuel saving, a large fuel-efficient twinjet is a very attractive offering. The main competition for the 777 is the Airbus A330, Airbus A340, MC Donald Douglas MD-11, and the Airbus A350. Fuel savings allow to offer lower prices to airlines customers while minimizing environment impact. Pilots are given extensive training themselves with all the system aboard the aircraft and how to operate it. That's all from my team. Thank you.